We are on our third day of parametrics, and we're going to be talking about motion along a curve today, but with a calculator. Tips to use your using your calculator for motion along a curve problems. Number one, remember that for all FRQs, you must always show what you are doing to obtain your answers. Never write a decimal answer or any answer without writing how you got it. You will not get credit for it, even if it's correct, if you don't say how you got it. Students sometimes don't do this when they have a calculator in their hands. When you do that, if you just write the answer and you use your calculator to get it, or you did it in your head, it's called a bald answer. You won't get credit for it. When units are shown, some problems they ask for units, and a student doesn't know how to do the problem, but they know the units, so they just write units. Those are called dangling units, and you won't get credit for that either. They have to be attached to something. So with that in mind, let's pull out our calculator. I'm going to be using the TI-84 Plus for this video. It's my most comfortable. It's the calculator that I am most comfortable with. All right. Number one, a particle moves in the xy plane so that x is equal to that function, y is equal to this function, and they give me, we're only going from 0 to 2 pi. What distance does the particle travel between the two x-intercepts? So first of all, I see that I'm wanting the distance the particle travels. I know my formula for that. The distance the particle travels is the integral of the speed. So the integral from time A to time B of the square root of x prime squared plus y prime squared dt. I know that. And it's easy to get x prime and y prime. So I know everything what goes in here. I know everything about what goes inside the integrand. What I don't know are these two times. So I need to find out what times the particle is at these two x-intercepts that it's talking about. Well, an x-intercept occurs when y is 0. That's what makes an x-intercept. So I want to take our y-coordinate and set it equal to 0. Now I know that this would be very easy to solve by hand, but I'm going to pretend that it's not easy to solve by hand because I'm going to let the calculator do that for us. So I am taking, let me get it to where it doesn't, there we go, have that glare to it. Okay, I'm going to put the left side in for y1 and the right side in for y2, where in my calculator now x is t, right? So my solution should be wherever the x coordinate is 0 here. So I'm going to only go from 0 to 2 pi because they told me to. Time is only from 0 to 2 pi, so that's all I want to see. My ymin and ymax, I'm just going to make it -4 to 4. It really doesn't matter as long as I can see 0. So I'm going to do that. And I see my two x-intercepts. So those two times are the two times when the particle is at the x-axis. So second calc 5, let's go find those. Enter, enter, and I'm going to approximate this to be a 1. My guess is 1. And that'll give me that first intersection point. So I'm going to say at t is equal to 0.5235 ... I'm going to go, before I lose that, I'm going to go store that in for A, and I'm going to go say that I'm putting that in for A. So go to my home screen, take that x coordinate and store it in for A. Now my calculator thinks that is A. Let's go back and get the other intersection point. So second calc 5, enter, enter, and then this time I'm going to guess maybe 3 to get that intersection point. So, and 2.6179 dot dot dot, and that is going to go in for B. You do not have to write the dot dot dots. You have to write at least 3 decimal places correct. At least 3 places after the decimal correct. I'm going to go and store that in for B. X store B. So now my calculator thinks that is B. So did I say what I did to get it? Yes, I did. I didn't just go and find it on my calculator and write these 2 times down. Now I want the distance the particle travels, right? So that will be the integral from A to B of the square root of x prime squared plus y prime squared. All right, our calculator can do the derivative by hand, and I know it can do the derivative by hand, but I'm going to, this is really easy for me to take it would take more time for me to have the calculator to do it than for me to do it. So I'm just going to do this myself. So the derivative of the x coordinate is 4 sine t. The derivative of the y coordinate is negative 2 cosine t dt. Okay, so this was x prime of t. This is y prime of t. All right, back to our calculator. So I'm going to need math 9 for integral, math 9, a to b square root parentheses 4 sine, and again in my calculator I'm going to use x for time. Make sure you get your parentheses correct there, plus negative 2 cosine t all squared. Do I need that negative? No, I don't need that negative at all. But I'm going to do it just to copy it down exactly. And then we have x at time is our what we're integrating with respect to, but in my calculator time is x. So I got that this particle travels a distance of 7.347, and now we only need to give those last these 3 places, and we're done. So you guys, do not round these 2 times. Do not round until you're at the very, very end. Use the entire number here. To use the store function to store those so that you're using the entire number. If you round too soon, your final answer may not be correct to the 3 places it has to be correct to. And if this last place, even that last place, if it was off by just 1 digit, it would be wrong. You would not get the answer point for that. So don't round until the end. Use the store function. All right, in this next one, in this last one, we have an FRQ. Now if I have an FRQ, I treat this a little bit differently. I use my my y equals screen more intensely because we have things that are used over and over again. Alright, so this is an FRQ. My tip for you for every FRQ where you're dealing with particle motion is this. In for y1 in your calculator, put x prime. In for y2, put y prime. And that goes not just for this one, but for everyone. If at all possible, you do that. Sometimes you're not going to be given that information. Sometimes you can get the information, and if you can, do it. So for this one, they gave me the velocity function. And I know if they give me the velocity function, they're giving me x prime and y prime. I know that. But is it explicitly given to me? No. It's just because I know what velocity is. So the first thing I'm going to do in this problem is I'm going to say x prime of t is sine of t cubed. Y prime of t is cosine of t squared. I need to say that if I'm going to use x prime and y prime, which you know we will on these problems. So I need to say that. Yes, they were given to me, but not explicitly. They were given to me as in v, the velocity vector. I need to write those individually if I'm going to use them. All right. They also gave me that at time 2, the particle is at position 7, 4. So they're giving me x at time 2 is 7, and they're giving me y at time 2 is 4. They're giving me those two things. Okay, part A. Write the equation of the tangent line to the curve at the point where time is 2. Well, writing the equation of a tangent line, I know what to do for that. I need a point and I need a slope. If I get those two things, I can write the equation. So first point and then slope. Or first slope and then point, whatever. Do them both. The point where t is 2 was the exact same point that they gave me. X of 2 is 7, y of 2 is 4. The slope. Well, slope is dy dx. Slope is dy dx, which in parametrics is dy dt over dx dt. Or another way to say that is y prime of t over x prime of t. Yeah? So dy dx when time is 2 is y prime of 2 over x prime of 2. So I just realized that I said to put x prime in for y1 and y prime in for y2, but I never did do that. So I'm going to go do that now. I'm going to clear out that screen from problem 1. And in for y equals, I'm going to clear those out. In for y1, I'm putting x prime of t, which was our sine of t cubed. In for y2, I'm putting y prime, which was cosine of t squared. Okay. All right. So now I want y prime of 2 divided by x prime of 2. Well, y prime is stored in for y2, x prime is stored in for for y1. So on my home screen, I'm going to do y2. I'm going to go pull out my y2 at time 2, divide by y1 at time 2. Remember, the way to get to those y's is under F4. So you want to do alpha trace to get to F4. So this will give me the y prime at 2 divided by x prime of 2. And we get negative 0.6606. Give at least 3 places after the decimal point. So our equation of the line will be y minus the y coordinate of our point is equal to the slope times x minus the x coordinate of our point. And that would be a safe stop spot. We just stop right there. Next up, find the speed of the particle at time 2. Well, speed is the magnitude of the velocity vector, which is the square root of x prime squared plus y prime squared. And we want that at time 2. So I want the square root of x prime of 2 squared plus y prime of 2 squared. That will be the speed at time 2. Go back to my calculator. Okay. Square root, parentheses, y1 at time 2 squared plus y2, parentheses, y2 at time 2 squared. 1.185. Give at least 3 places after the decimal point. Sorry. All right, part C. For what value of time between 0 and 1 does the tangent line to the curve have a slope of 4? Well, the tangent line to the curve is dy dx. We want dy dx to be 4. So at what time is dy dx 4? And then we're going to find the acceleration vector at that time. So dy dx is dy dt over dx dt, or y prime of t over x prime of t. We want that to be 4. I'm going to let my calculator do it for me. So what I see here is an equation, and I'm going to let my calculator solve that equation. I'm going to go to the y1 screen, and in for y3, I want y prime over x prime. That will be y2 over y1. So y2 divided by, not minus, divided by y1. In for y4, I'm going to put 4 in and see where those two intersect. Now right now it's going to be graphing 4 things. I don't want it to graph 4 things, so I'm going to turn off the graph of x prime by pushing enter on its equal sign, and turn off the graph of y prime. Now it's only going to graph the 2 things that I want it to graph. We only want to consider between 1 and 0. So go to your window and only consider between 1 and 0. So 0 and 1. Okay? Also, our y component, our y, we're going to be graphing the line y is equal to 4 here. So I want to go above 4 on my y max. Maybe I'll go to 6. That'll cover my bases. So we should see a value of t that makes the slope 4 when we graph. There's my slope, and there's my time 4, and sure enough there's 1 spot. So let's find the intersection. Second calc, and then 5 for intersect. Enter, enter, enter. My calculator had a little bit of a blip on there. But anyway, there's that one time. I know I'm done with the intersection when it says intersection. So this occurs at t equals 0.61648 blah blah blah, and I am going to put that in for A. So go to my home screen, store that x value in for A. Now my calculator thinks that's A. I'm doing that because I know that we were asked to find the acceleration vector at that time. So the acceleration vector at that time will be x double prime at that time, y double prime at that time. In my calculator, I have x prime and y prime, so I'm going to need the derivative of my y1 and the derivative of my y2, both at that a value. So, math 8 for derivative with respect to x of y1 at that time a is 1.109. Give at least 3 places after the decimal point. And then to get y1 in there, I'm going to scroll up so I don't have to retype the whole thing again. Scroll up, hit enter, and then go over and change y1 to y2 and get the y component of the velocity vector, not velocity vector, of the acceleration vector at time a. At least 3 values after the decimal point. Lastly, we're going to find the position at time 1. We know the position at time 2. We want the position at time 1. We know x prime and y prime. This is screaming for me to use the fundamental theorem of calculus. When we're finding the position, you guys, use the fundamental theorem of calculus. So, and the position is going to have an x component and a y component. X at time 1 minus x at time, what time were we given? Oh, we were given time 2. So I need to put 2 first. I'm going to put 2 first. X at time 2 minus x at time 1 will be the integral 1 to 2. Remember, whatever you put here has got to be up on top of x prime. Since I already said what x prime is, I don't have to write sine of t cubed here. I can just leave it x prime. So x at time 1 will be, well, the negative of x of 1 would be the integral minus x of 2. The positive of x of 1 would be x of 2 minus the integral, like that. So use your good algebra to solve that for x of 1. I should have gone ahead and written what x of 2 was. What was x of 2? X of 2, I should have written that just now. X of 2 they gave us was 7. So x of 1, x at 1 will be, so I'm putting this in my calculator, 7 minus the integral 1 to 2 of x prime, which is stored into our y1, and that will be 6.781, at least 3 places after the decimal point. And we will do the same procedure for the y component of the position. Y at time 2 minus y at time 1 is the integral 1 to 2 of y prime, which is stored in for our y2. So y at time 1 will be y at time 2, I almost did it again, y at time 2 is 4 minus this integral, so y at time 1 is 4 minus the integral 1 to 2 of y2, 4.4431. So write at least the first 3 you see. So the position at time 1 is, And again, you can use the vector notation or parentheses notation. Either one is fine. I usually do whatever they gave me, and this time they gave me parentheses, so I would probably use parentheses, but either way is perfectly fine. So those are some tips on using your calculator to solve motion along a curve problems.